Welcome to our Keysight booth at DesignCon 2025. This year we are celebrating 30 years of DesignCon and 10 years of Keysight. By the way, a side fact, do you know that Keysight and DesignCon have the same roots in Hewlett-Packard? But now join us on our tour around our Keysight booth and see what we brought for solutions to enable the next generation of technologies.
Greetings from DesignCon yet again. Hi everybody, my name is John Calvin. In this station we're showcasing our IEEE 802.3 DJ conformal test package. This package is running on a high bandwidth UXR oscilloscope, and we have a compliant solution that currently is tracking the draft 1.4 version of the specification in terms of being able to do jitter, SNDR, some of the complex operations that are required for physical layer validation and this electrical specification that's emerging here this year. And we provide a full turnkey automation package that will do these tests for you. This is really important because some of these tests are extremely challenging. These measurements, particularly the jitter decomposition, SNDR operations, are things that are highly error prone. So having an automated test package being able to walk through these tests is really strategically positioned for customers who need to compare results across different labs and things of that nature. So on the screen in front of me, we have the UXR oscilloscope. It's doing its jitter decomposition here, modified 12S jitter based on some spec revisions we made recently. And up on the screen behind me here, we see the 802.3 DJ application. It provides a framework that allows you to select key measurements. You can run them, repeat them, build a report, and generate an output file that tracks the electrical performance and gives you a reporting mechanism. Very good. Thank you very much.
Hi, I'm Fabio Pittala, and I'm product planner at Keysight Technologies. The introduction of 448 gigabit per second interfaces may happen sooner than expected, and this is because of the booming of AI applications. While at 224 gigabit per second, PAM4 has been used for both electrical and optical interfaces, at 448 gigabit per second, the modulation format is still a topic for researchers. Today, we are demonstrating 448 gigabit per second by using 150 gigabaud PAM8 and 174 gigabaud PAM6. We show unprecedented signal quality, and we also demonstrate 200 gigabaud with PAM4. We use the M8199B AWG for signal generations. We use the N1046A DCA for signal analysis, and the 110 GHz UXR real-time oscilloscope for BR measurements. For all modulation format, we show OpenEye, and we measure BR of 2 times E2-5 for PAM8 and 2 times E2-6 for PAM6. We also do an experiment with a state-of-the-art fixture which is designed for OSP modules, and we can demonstrate 140 gigabaud PAM8 and 160 gigabaud with PAM6.
Hi, my name is Michelle Havard, and I'm a product manager with Keysight. Today, I'm going to share with you 2 different solutions on the show floor here. One is a hardware-based solution. We have a brand new tester called the Interconnect Network and Performance Tester. It's PAM4 signaling at 112 gig SerDes speeds. What we're showing on the tester is layer 1 measurements. We're looking at link integrity, but we can also use all kinds of system level testing parameters, layer 1 through 3. Also, we have an AI fabric builder. This is a software platform that allows you to test AI infrastructure by tweaking different knobs in the system, primarily through collectibles and collective communication and workloads.
Hi, this is Randy White with Keysight. I'm here at the DesignCon booth showcasing next generation memory validation. Here we have a cadence test board that's transmitting LPDDR6 traffic. We have a UXR high bandwidth oscilloscope, and on this oscilloscope we have an LPDDR6 compliance application. Now this application performs all the tests that are specified by JEDEC for this next generation memory interface. We have voltage, timing, and a number of other tests. For this example, I want to call your attention to a new requirement for LPDDR6, which is an extrapolated eye mass test. This is what you see on the screen here. This means that we measure the eye and we extrapolate this eye result down to a 1E minus 16 BER.
Hello, my name is Mike Resso. I'm a signal integrity application scientist at Keysight Technologies in the Internet Infrastructure Group. Welcome to DesignCon 2025. We're now looking at a 1.6 terabit demonstration, and we're looking at our flagship 16-port 67 gigahertz vector network analyzer, and we're testing a Samtec NovaRay mezzanine connector with some high-quality fixtures. What's important when analyzing these types of devices is you have to measure calibrated S parameters and then drive that analysis of your S parameter file in multi-domain. So here we're using physical layer test system software, and we've actually got time domain in the impedance profile. We've got frequency domain looking at return loss and insertion loss. And of course, it's critical we look at PAM4I diagrams. As you can see, we're actually able to implement equalization like DFE and CTLE, and also we can de-embed fixtures and cables, so we're strictly focusing on the device under test, and we're not degrading the performance of that device under test with lossy fixtures. So, in summary, we encourage you to use the highest frequency vector network analyzers and signal generators that you can, and then do all the analysis necessary for compliance in IEEE and OIF standards. Thank you.
Hi, I'm Rick Eads. I'm a Principal Strategic Planner for Keysight Technologies, and here I'm demonstrating PCI Express 7.0 capabilities. So we have two demos. One is on the transmit side, where we are demonstrating the ability of this actual silicon to achieve a SNDR value in excess of 34 dB on a UXR oscilloscope. Likewise, we also have an M8050 BERT engaged in a loopback test through a channel that is in excess of 45 dB and achieving again, spec exceeding 1 error in 10 to the 9th bits, where 1 error in 10 to the 6th bits is the spec limit. So this demonstrates that even today, with the spec at 0.7, not yet at 1.0, we have silicon available in the marketplace that achieves the required performance of the PCI Express 7.0 specification. Thanks.
Good morning. I'm Jet. I'm responsible for Keysight's USB solutions. Today, I'm very happy to showcase our partner Synopsys' USB 4 V2 PAM3 PHY running at 80 gigabits per second with amazing receiver performance. The BERT is putting a stress cocktail using the long channel compliance test, and the results are right here. In red is the spec TER of 1e to the minus 8, and on blue is the tested TER. You will see that lots of margin, e to the minus 11 versus a spec of e to the minus 8. Secondly, you will see that the blue line, in this case 850 seconds, is a very reliable, consistent receiver performance from the Synopsys product. Thank you.
Hello everybody, my name is Tim. I'm a Signal Integrity Application Scientist at Keysight. Welcome to the Keysight EDA demo station. Today I'm going to show you 4 things. Number 1 is the Keysight Triplet PHY Designer. It leverages 3 big things. First, UCIe 2.0 and BOW standard. It understands DDR and QDR clock lines, and as well as the VTF compliance. It makes it very easy for you to do UCIe compliance. Number 2 is a system designer for PCIe. It's a system-driven and standard-driven analysis for PCIe. Number 3 and 4, if you do have a board that you want to do signal integrity or power integrity analysis, we have ADS, SI Pro, and PI Pro here that you can leverage to analyze your PDN or your signal traces. Thank you for watching.
We hope you enjoyed the tour around our booth at this year's DesignCon. If you have any further questions, do not hesitate to contact your local Keysight representative or visit keysight.com, or even leave a comment below this video. So thanks for watching and see you soon.